I need to, and it's all good because this is going to be videotaped. So you guys can, or this will be videoed and recorded and published to our YouTube channel, so everybody can, watch it again for future reference if you wish to. Okay, so welcome to our webinar series for 2020, April 2023. I think this is the first one we did this semester, if I'm not mistaken. Could be the second one. So anyways, we're usually our webinars have become more of a, hey, these are some of the cool things that researchers are using DesignSafe for and the cool data sets that they're publishing with. So we're decided to go back to the basics and actually do a kind of a webinar tutorial on some of the cool things that we've discovered playing with DesignSafe and some issues we may have come across and some really cool workarounds for that issue. And so that's kind of what I'm going to be talking about today on about DesignSafe. So let me proceed here. By the way, I got two monitors here, so I'm going to be staring at this monitor where my slide projections are, but I'll be looking back and forth between my code that I'm going to be here and to you all at the camera. So hopefully that works for you all. Okay. Anyways, before I get started, I want to say we really, really do appreciate you all's feedback. This is a QR code. You can go and scan that with your phone. It takes you to a survey, essentially saying, hey, how did I do? How are we doing as an organization? What would you like to see in future webinars? And do you have any ideas of what some topics of future webinars could be? So we would really love to have your feedback and continue doing these webinars for you all. Okay, so today's webinar is Introduction to Scientific Programming with Python. I'm Charlie Day. I am the Director of Professional Development and Training here at the Texas Advanced Computing Center. I'm also the lead training person for DesignSafe, even though honestly, it takes the community. So it's a group of us that actually do these webinars and put these webinars together for you. And I hope you guys get something from this. So I've been here at TACC for about 12, 13 years, coming in originally as a software developer, and then working my way into more of the education side of things because somebody heard that I enjoy teaching. And so, hey, they put me in there. Some highlights of my career have been, I was a research consultant for NASA Ames. This was maybe 15 years ago on an ongoing project about doing computational immunology. And I'm currently in the process of getting a master's degree in cybersecurity because, well, why not? Cybersecurity is kind of an interesting little, just on a side note here, cybersecurity is an interesting degree program because you are learning so many different aspects of the computer tech world, everything from databases to biometrics to proper programming techniques to coding to make sure that there are no vulnerabilities in your code. So yeah, and it's interesting to see how many mathematical models that we've solved. I'm going to give you an example of immunology can be applied to cybersecurity. It doesn't matter if this virus is running loose in a pandemic among a community of people, or if a virus is running loose among a community of computer systems and networks. Kind of the same model, different pieces. So that scientific programming background is why I decided to kind of look at doing scientific programming with Python. I mean, it's nothing new. We've been using Python for scientific programming for a very long time. But what Python gives us is the ability to kind of morph it as we need it, right? So Python is a great programming language. We use it for our DevOps, right? A lot of DesignSafe is written in Python. We do it for graphics work. We do it for animation. We use it for checking our systems, and we do it for writing scientific code. And that's kind of what our plan is today. And hopefully in the next hour and a half, we can give you some tidbits on being able to do your scientific coding on Python and make it easier for you. The way I kind of like to approach this, the way I do a lot of things that I approach, is we kind of need something to solve. I mean, I can walk through here and take you through a tutorial about Python, showing you how all the variables work, showing you how to do loops properly, and conditional statements and functions and objects and all that fun stuff. And I can do that if that's what you wish. You can do that in a survey saying, you know what, let's stay away from this side and do more classroom kind of stuff. Or we can do what I like to do, which is solve something. So that's what I kind of pulled together, some bits and pieces here or there, to pull together and solve something that I would say 90% of us on this call are probably familiar with, which is the heat equation. So we're going to try solving the heat equation in Python. We're going to code it up using a simple stencil, so it shouldn't be too difficult to follow. I promise I will keep the math at a bare minimum, mostly being that my dad was a mathematician. I'm more of the computer guy, and so I'm going to be more on the computational side of things. But I will have to kind of dig into the math for those of you who are new to the heat equation. I'm hoping that while we're trying to solve and write this code, okay, because I'm going to do this thing live, so cross your fingers that it works, that we're going to learn some basic syntax for Python. I'm going to hopefully demonstrate some good techniques in Matplotlib, and maybe some alternative techniques that we've never heard of, or maybe you've never heard of. We're going to demonstrate some techniques in Matplotlib to view our results. We're going to figure out, now this might be kind of weird, we're going to figure out if we can animate it. Matplotlib has this really cool animation function. We're going to see if we can figure out if that can work in DesignSafe or not. If not, let's figure out if we can come up with an alternative route. And then finally, we're going to try and save our data into a CSV file using Pandas. Now, here's the thing. We're going to do a lot of this live, so we're hopefully going to get this thing working. And we'll see if we can figure out how it all kind of goes together. And hopefully I'll be dropping enough tidbits along the way that you'll find useful for your scientific code and scientific research. If anybody has any questions, jump onto the chat feature. And we'll see if we can go ahead and answer those. We have some people on the call who are knowledgeable in Python, and they can manage and answer some questions. If any question gets asked and there's somebody on the call who knows the answer to it, feel free to answer. We're a community here. DesignSafe is a community. And so we kind of work together as a group and hopefully get some of these done. If I find a bug, if I do a bug and something blows up in my code, feel free to, unmute yourself and say, hey, Charlie, that's not going to work. And that's fine too. The joy of live coding. All right, let's cross our fingers and see if this works. Okay, so I'm going to go through some basics here first. First steps, what are we trying to solve? Well, we're trying to solve a heat equation. Basically, it's just a partial differential equation, right? And we are going to manipulate it into a 2D Cartesian access system, so we all kind of see it. And so that is how we're going to translate it, du dt minus some coefficient times d square u over dx plus d square u over dy equal to 0. So that's what we're going to try and solve for. T is our time. It's our temporal variable. X and y are spatial variables, so we can kind of see how things move. And the idea is we're going to solve for u for every x and y. And we're going to iterate that over time and see what happens. Hopefully we'll get some cool results, and also hopefully we'll be able to graph this thing. And that's really what I want to see, because everybody loves pretty pictures. Numbers gets you only so far, but honestly, if you put a pretty picture out there, people exactly understand what's going on. Okay, so hopefully everybody's still with me. So how are we going to do that? Well, we are going to use a finite difference method, and we're going to approximate it and then remove the limits, right? So instead of using a differential and limit symbol, we'll just use the delta symbol, all right? Because we are going to have, things are going to change through time. So we're going to change the value of x, change the value of y, calculate for the next time, change x, change y, calculate for the next time, and so on and so forth. Yes, I kind of even put that in here. I'm sure some of you are saying, well, this is awfully simplified. Yeah, it is. Because we have to use Taylor's expansion. And yeah, look, Taylor's series, it comes back into play every time. And so we're going to just kind of cut it down, make it slimmer for us to be able to use and approximate. We're going to look at a grid. We're going to look at time, and we're going to look at the x-axis and the y-axis, and of course, change x all the way across. And we're going to try and figure out how to calculate this. Right now, this is not something we can calculate using a computer system. This is math. We have to get it from there to something we can actually calculate and write code on. So how are we going to do that? Well, we're going to take this, which is our heat equation using the finite difference method that we kind of defined a little earlier. And we're going to take this, rearrange it, set delta x and delta y equal the same, so it's easier for us to manage. And we get that equation, where gamma is equal to that coefficient delta t over delta x squared. This, as you can see, looks a lot more manageable. That is actually something we can code, and we can code that pretty easily. So before we get to coding that, we're going to do a little bit of some details, some initial conditions that we're going to put through. We're going to solve for a plane, and yeah, this is kind of a crude drawing, but it makes sense, where our initial condition is going to be 0 degrees all the way across the board. I think what we're going to do is we're going to set the top border initial condition equal to 100 degrees Celsius. And if you all understand, remember what the heat equation is, go back to your original engineering, I guess sophomore, junior year in college type of stuff. And remember, what we have is a big giant plate, and we're going to put a heat source against one of the edges. And we're going to put essentially the rest of the edges on ice. So and that's our starting condition. So everything is on ice, so it's sitting at 0 degrees. And then we're going to have one edge at 100 degrees, and that's our initial condition. What's hopefully going to happen is that heat, when we remove the ice and we start our simulation, that heat should transfer through the rest of the plate, and we should be able to see how that heat actually works. Okay, we're going to have a delta x value of 1 and alpha value of 2. That is essentially going to be something that's stable for our equation to calculate, so it's going to be rather easy to do, and not have to experiment around too much. We're going to numerically then calculate the temperature everywhere denoted by an I and J, so we're going to iterate through I and J, and then we're going to iterate that over time, and we're going to call that K, right? So here we go, back to our equation. U superscript K plus 1, U sub ij is equal to this entire equation. We're just going to go and calculate i's and j's. And every iteration will be the next iteration of time. All right, so hopefully everybody's still with me here. Let's see if we can do this. All right, so to do this, we're going to need some modules. We're going to need to plot the thing. So we're going to use this thing called Matplotlib. We're going to do some numerical stuff. So this is going to, we're going to need NumPy. And we're going to be doing some, we're going to want to save our data set into a CSV file. And for that, we need Pandas. And I threw this other thing in there called image.io. It's something I came across while I was trying to figure out how to do this. And it's actually something that's kind of cool, and it might be beneficial for us to manage. And then, of course, we need some functions. We need to calculate U. We need something to manage our plots. And we need to be able to essentially tell a better story through these functions. Okay, so that is all of our, I guess that's our laundry list and our things that we need. Okay, so let's do this. I'm going to exit out of this. I'm going to go to Python or Jupyter or DesignSafe. DesignSafe.ci. So if you've never been to DesignSafe before, or if you're new to it, DesignSafe is, close this out. DesignSafe is essentially a cloud-based research environment. It is meant to hold your data sets. It is meant to hold your code. It is meant to be able to help you with your analysis. It's allowed to help you connect to our supercomputers, your TACC, for entirely being our biggest machine, or currently our biggest machine. And it allows you to be able to share your data sets with other researchers. It allows you to use other researchers to use your data set as kind of a stepping stone and build their own data set, all in one nice convenient area that is available to you, thanks to the National Science Foundation and TACC and all of our partners here on DesignSafe, UCLA being one of them. Thank you, Scott. Okay, In DesignSafe, really quick rundown, we have our workspace. Our workspace has our tools, has our data depot. Those are probably the two important parts for today's talk. But we also have this thing called the Recon Portal, some simulation research tools, and our user guides, and some use cases. Then we have our Learning Center. That's where all of our training material is archived at, and some more information on our summer programs, and the DesignSafe Academy that's going to be coming up here soon as well. And then the different facilities we have through NERI, and that's essentially our umbrella group is NERI, the Natural Hazards Engineering Research. And then some information about the community itself, and then our news, and then help for you to be able to fill out frequently asked questions, our user guides. We have virtual office hours from some of our taxsters and some of our DesignSafe colleagues and researchers that can help you answer some questions, submit some tickets, etc. Okay, so kind of a quick rundown. I'm going to go to the workspace. I'm going to go to Tools and Applications. Under Tools and Applications, you will see we have kind of a bunch of tab stuff up here, and we have our Data Depot browser, and it asks us to select an app. All right, that's what I'm going to do. Under Analysis, there is a couple tools that are available to us, one of which is a Jupyter Notebook. So I'm going to click on Jupyter, and I'm going to click Launch. So for those of you who, since I already actually have my Jupyter Notebook launched earlier, there sometimes comes up with a choice for you to make. One of the choices is the Classic, and one of the choices, the new Jupyter Lab. We want to launch with the new Jupyter Labs. And since I'm already in here, it didn't give me that choice because I already have mine launched. But we want to use the new Jupyter Lab, and this is what the landing page looks like. Really quick, we have on our root directory, we have this thing called community data. Community data is essentially a area for like sample codes, some previous webinars that we've done. The code will be published there, and you can kind of dig through there and find some use cases that would apply to your case. There's also sample data sets and that kind of fun stuff. My data is where all of your data sits. My data is kind of large because I've got a bunch of stuff in there. And when DesignSafe first launched, honestly, I should have really thrown a lot of this stuff into folders. I did not, and I'm regretting it now because there's a lot of stuff that I really should be putting into folders and make it more organized looking. But that's on me. I will suggest, though, and will ask that you actually select the My Data folder out of this. We also have NEAS. These are previous NEAS published projects, and then we have our NERI published projects coming out of here and this projects folder. We're going to concentrate our efforts today on the My Data. So that is kind of where you want to go. We can manage all of this stuff through Jupyter Notebooks, or we can manage this through TACC or DesignSafe's Data Depot. So there's a very similar pattern between the two. Okay, so back to Jupyter Lab. I'm sorry, I hope I'm not switching around too much here. I'm going to create a new folder. To do that, this icon up here, click on plus. New folder pops up in the bottom, no name. So I'm going to call this ISP, Introduction to Scientific Programming, Python. All right, and it's automatically put that in the right place. I'm going to double click in that. Nothing in there, it's blank, it's empty, so I am all ready to go. Here is our landing screen for our launcher in Jupyter Labs. We have the IPython 3, which is what we're going to use today. There's also Julia, and there's also R. Those are actually really, really cool environments and cool programming languages. I do suggest maybe you take the time sometime and learn a little bit of R or a little bit of Julia. I use R quite a bit as well. It's a great language for handling data sets. So Python is what we're doing with. And I want you to keep a look down at other things we have here as well. We have the console, Python, Julia, and R. We have a terminal window, text viewer, markdown files, etc. All right, so we're going to launch our Python notebook by just clicking on Python. That brings us here. Some of you might take a little bit longer to get through since mine's already up and running. A little quicker. We're going to create our first notebook. I am going to rename my notebook. to Introduction to Scientific Programming, Python, the name. For those of you new to a Jupyter environment, Jupyter is set up for essentially what it's set up based on cells. All right, these cells can be code cells like we have here. So in a code cell, I can type print hello world, and I can hit Shift Enter to run it, or I can click on this play button. So Shift Enter runs it and gives me a brand new cell. Notice also it gave me the output to the little piece of code that I put in there. I'll tell you what, honestly, I always love to start live coding presentations with hello world because it works. I give myself a pat on the back. I feel good about it because stuff compiles, code works. And so always start out with the hello world and give yourself that little bit of boost. And it's always kind of nice. All right, so hello world works. We also have these things called markdown cells. Markdown cells is kind of like HTML, but a little bit different. So I can say, hey, I'm going to start out with a header saying this is my first notebook. And Shift Enter. Boom, we have a header. You can do subheaders. Let's do, oops, now we got to go to a code cell, change that to markdown cell, and say subheader. Let's do some science. All right. So let's get our notebook going. The first thing we kind of need is what we said in our little bit. Nope, wrong slide. Let's put that one. What we want to do? Well, we need Matplotlib, NumPy, Pandas, and this image.io. We'll come back to that in just a bit. First thing, I'm going to go back to my notebook here, and we need to get those modules. So the way Python is built upon modules. The modules are little bits and pieces of code that you import into your program to essentially use and take advantage of what they're giving you. So the reason I'm going to dictate or try and talk at the same time while coding. The reason we like Python so much is, especially as a data scientist, Python is really, really good at collecting stuff. I highly recommend, we're not probably going to dig into it this much because this isn't really that much of an intro to Python as much as it is an intro to Python programming. But one cool thing that Python has is this thing called a list. And a list allows you to collect whatever you want. It could be a list of integers, it could be a list of reals, it could be a list of strings, it could be a list of objects, it could be a list of photos and pictures and JPEGs or whatever. Or it can be a combination of all that. So it can be a list that contains some strings and some integers and some floats and some values and some photos and some other objects and some other lists. So you can have lists of lists. So you can see this thing just growing. So that's why we like Python, is because it does these collections of stuff. And honestly, as a data scientist or a researcher who collects data or creates data, all you're doing is creating stuff. So Python comes into perfect play over there. I'll also say one more thing. I am not a Python expert. In fact, I would say the ultra expert Python hacker are probably the guys who actually wrote the language. The reason I'm saying this is there's a lot of things we do as computer scientists, as computational coders, as system and software engineers that we're used to doing. And we might find that Python could be a little slow in handling some of that. But if you are basically an expert in Python, you're a Python master, essentially what happens then, it allows you to know all the little nuances that are in the code that helps you speed it up. We're going to look at some of those nuances today, especially when we build our mass array of values of U. And we'll see if we can use some of those tricks to kind of make our lives easier. All right, So first thing I need is Matplotlib. I've got NumPy as NP. So we import the module and then we give it an alias because that cuts down on how much we're going to type. So I don't have to type NumPy. I can just type NP. We need Matplotlib. Matplotlib is a freaking gigantic module. So usually what we do is we just pull out the bits and pieces as that we need. So matplotlib.pyplot has PLT. I'm also going to import. Now, like I said, we want to do some animation stuff. So I'm going to go ahead and import matplotlib.animation. And like I said earlier, I'm going to be coding this thing live. So we'll see if things work and see if things don't work. So I'm going to pull that in as animation. I also am going to import one more thing from, so now we can also say from certain libraries. So from the Matplotlib animation module or submodule, I'm going to import in a specific part, which is called Func Animation. Now, if you haven't played with Func Animate or Func Animation, it's actually kind of cool, especially the way it's set up. Hopefully, we'll see if it works or not. Okay. Now, the way Jupyter Notebooks are set up, I can just keep coding all I want, or I can just say, hey, this is my one cell of getting everything imported, and so I can run stuff without having to import them again. So I'm going to hit Shift-Enter here. Oops, I mistyped the word from. And, oh, there's a bunch of stuff in the chat. Did somebody actually catch? Somebody did catch my typo. Maybe not. Yep, somebody did. Thank you, Bushra. I appreciate that.
One person did. This is where you would be handing out chocolates if it was live.
I would be. I have chocolates right here to hand out.
Yeah, we are having people having trouble accessing Jupyter and DesignSafe. So if you have your own Jupyter environment, I think you can follow along with that. Otherwise, maybe they could come back and rewatch the video and follow along live. We're getting gateway timeout errors.
Yeah, that could happen. We have approximately 80 people online right now. Yeah, so that could definitely cause a problem to everybody trying to launch their Jupyter sessions. My suggestion is maybe take a break and not launch it quite yet, and restart it and then launch it in a little bit. There are people online who can probably help you get things going if they need to. So my apologies for that, but yeah, that can't happen. Everybody tries to access it at the same time. Okay.
But
so
Charlie, people could use their own Jupyter environment if they have a computer, Google Colab or something like that.
Yeah, if you want Google Colab, you can go to Jupyter Labs. They have a freebie Jupyter on there as well that you can use without an account. That works just fine. If you have Jupyter installed on your local machine already, go for it. In fact, if you have an installed local machine, there are things that are going to work pretty darn well. So yes, let me fix that typo. Okay, the next thing we need is, sorry, I should have the chat window open earlier. Move the chat window open here. All right, so the next thing we need is setting up our variable. Now we have this plate that we're building, right? So we need a variable that's going to manage how long that plate is. And I'm going to give that thing, the plate, to be 50 units. The next variable that we need, so you know what I'm going to do? Sorry, I'm going to create another cell. I'm going to move, whoops, I'm going to move that cell up. Come on, there we go. And I'm going to make this into a markdown cell. I keep forgetting that, you know what makes really good code? Commenting stuff. All right, we have our libraries. Now we need our variables. Set, plate length being 1. And we need to define our max iterations. So max iterations for time. And we need what our alpha is going to be. And we need to figure out what our value of delta x is going to be, which we already calculated what those are. We just need to set those. Okay, so there we go. Now I'll look at that. I got a comment in there. My old computer science teacher would be very proud of me. Iteration, time, and that's the max time. I'm just going 1,000 for that. Then, of course, our parameters. I said we have alpha. I'm going to set alpha value of 2.0. and a delta X value of 1. Make life simple. I can hit Shift Enter here. Something I want to also keep an eye on is these numbers I'm creating. Yeah, these numbers, as I hit and execute a line, this is the execution order that that was received in. And that comes into major play when you go back and edit things around. All right, and now we need to calculate some variables as well. So we go back to Markdown. This is our calculated variables, which are going to be our delta t, because we want this thing to be stable. So we're going to calculate our delta t value based off of alpha and delta x to give us a stable simulation. And then we also want to calculate our gamma, which is that little bit that we showed you on the other screen. Okay, and so I'm going to hit Shift Enter here and pat myself on the back because I'm commenting my code. So delta t is the first thing we're going to calculate, and that is going to be delta x squared. So if you've never seen this double star notation before, that is essentially means raised to the power. So x squared would be x star star 2, x cubed would be x star star 3, x to the 4th would be x star star 4. Hopefully you guys can see what that pattern is. So that's going to be delta x squared divided by 4 times alpha. So that should calculate delta t. The next thing we need to calculate is our gamma, which was that value we saw on here, which is right there, which is alpha times delta t, delta x squared. So that is exactly what that's going to be. Alpha times delta t divided by delta x squared. All right, things are still looking good. Shift Enter. Yes. Oh no, I mistyped again. Go back to my chat window, see if anybody noticed it. Let's do that again. Another reason I really like Jupyter Notebooks is because you can break your code up into pieces and see if it's actually working or not. Okay, so there's our calculations. The next thing we need is to set up our initial condition. Essentially, hey, what are we going to be doing here and how are we going to be doing it? Well, we have this U, right? And U is of K and I and J. So it is going to be our plate length by our plate length, we're just looking at a square. And K is our time, so that's our max iteration. So we're going to create an empty array for U is, whoops, it's going to equal an empty array. So to do that, we do NP. NP is our numerical Python, and we're going to create an empty array. So empty. And what is this? What are the fields in there going to be? It's going to be, I think if I hit, yes, by the way, if you hit tab on something, it'll show you, or hit tab twice, it'll show you everything that you can add to that and how you would call it. So what I want is empty. So if I do, oops, E-M-P-T-Y. So if I wanted more information, I could just click on that and it'll tell me exactly how empty works and what the fields are. But I'm going to give you a heads up right now. What it takes creates an empty array based on some values you're going to be passing it. So I need an empty array of max iteration time, which is this 1,000, comma, how many values of X are there going to be? Well, it's our plate length. And how many values? So plate length, it's a square. And that should create our empty value of U. We also need our initial value of U, which means all the stuff in the middle is going to be initial is going to be 0.0. The other thing now, you're catching something. I put 0.0 instead of just 0. The thing about Python is Python does what we call, it's a little smart coding. You don't have to type it for those C programmers out there. I'm not typing integer u, I'm not typing float u. I'm just saying u equal to, u initial equal to whatever. I didn't give it a type. If I just give it a value of 0, Python is going to interpret that as being an integer. 0.0, now Python realizes, okay, u initial is going to be a float. So I'm going to say u initial equals 0. And now I'm going to give it a top value because we have our initial conditions. Remember that top boundary is going to be 100, because it's a square, so the top's going to be 100. Everything else is going to be 0. So let's go and set that up. 100.0, and those are going to be floats as well. U left equal to 0.0, and top, left, right, and U bottom is equal to 0.0. Okay, top, left, right, bottom. They're all to 0, top is equal to 0. That should be good. And now we have to, now that we got our boundary conditions set up and we have u initial equal to 0, now what we can go back is to our this guy here, this array we just created u. We're going to go ahead and set up u, and we're going to fill that up with those initial values. U underscore initial. I caught my own typo before anybody else found it. Okay, so now we got our initial condition set. We have a boundary condition set. Well, we don't quite have them set, do we? We have our boundary conditions defined, but we haven't set them yet. So let's do our shift enter again. I'm going to go ahead and take this guy. And I'm sorry, I'm doing this. I really should be commenting as I go. There we go. So this is going to be another markdown. I'm going to do a subheader 1, 2, 3, 4 in this case. 3 is fine. Calculate variables, set up initial conditions. Conditions. Oops. Thank you. There we go. Space. And shift enter. Another markdown cell. We're going to set up our boundary conditions. 3. Set up boundary conditions. All right, now for those of you who do C programming or conditions, for those of you who do C programming, I know what we have to do. We've got to set up a bunch of loops and set the initial values and go through the entire array or to set the first line and then everything else equal to 0. And we do all that through a bunch of loops. That's how we would do it in C++. That's the first thing I would think of how to do it. But Python gives us this really cool way of managing arrays using what we call slices, okay? So I can say u, and I'm going to give this designation of a colon. What colon says is, hey, in that first dimension, use all of our indices, meaning it's going to go from 0 to whatever the max index is, which is the first index is iteration time. So 0 through 1,000 is what we're looking at. The next thing we're going to do is I'm going to say, all right, we're going to do our plate length. We're going to go all the way from 0 to plate length -1 because its plate length is 50, -1 to 49. So plate length, if I spell it right, -1 to everything else. So from there on, plate length -1. And then everything. So what does that give us? That gives us that top line. That top line is going to be all the values for time, right? And the plate length -1, so 0 to 49, because 0 to 49. And we're looking at the very first value of y. So it's that entire first line is going to be u top, which is set at 100. And we did that through one line of code, which I think is pretty freaking amazing. It's awesome. One line of code to do that for us. Okay, now what? Now we need to set up our other conditions. We have the left and the right. Those should be easy because it's just everything, and everything to the value of 1. So from 0, everything up to 1 is going to be my left. That is going to equal u left. Then we have to set up right. So u colon, comma. Now what we're going to be looking at is, because it's the right, you're looking at plate length -1. Oh, wait, that's not right. There we go. It's colon because it's 0. And now plate length -1. You know what I'm thinking? I'm thinking I should have just had plate length equal to 49. No, I think I do need -1. Now I'm thinking of it. Plate length -1. And everything after that. So I'm going to put a colon there. That is going to equal u right. Oops, I wanted one more line in there before I did shift enter. And then it's good to see that it actually worked. And then of course we do the bottom, which is exactly the way we did the top, except now we are looking at colon 1 colon. Make sure I'm doing that right. Yeah, colon equals u bottom. That should be okay. That should set everything up, I hope. Yeah, that's right. Second guessing myself now, that's not a good sign. Okay, now comes the fun part, which is calculating everything. Now, the way we normally calculate is the same thing. We would go through our multiple loops. You know what? We can also use a stencil just like we did there, but I will be absolutely 100% honest with you. After this initial condition setup, you can do -1s, you can do -2s, and you can set everything up piece by piece. That gets really, really confusing really, really quick. So all I'm going to do is I'm going to create a function called define, and I'm going to call this calculate. And I'm going to do it the old-fashioned way. I am sorry, I'm going to do it the old-fashioned way because we're live coding this, and I didn't really have much lunch today, and we'll see what happens. So I'm going to do it this way: for k in range. Now, if you notice, I'm creating a function, so I'm using the def command or the def syntax. Def means define a function. What do we want to call this function? I want to call the function u, I'm going to call the function calculate. I'm going to pass a value of u in there. And then what are we going to do with that? Well, we're going to figure out what this is. So essentially, we're going to pass something out. I can also pass something back with it. So that's what we're going to do. Notice, for those of you new to Python, there's no curly braces, there's no square braces, and there's nothing. There is, however, an indentation. That indentation could be any length. It could be a tab or it could be spaces. But you have to be consistent. Meaning, if you're going to choose tab, make sure it's tab all the way across the board. If you're going to make it 3 spaces, make sure it's 3 spaces all the way across the board. Okay, so for k in range. Now, the way loops work in Python, it gives you, we have this thing called range. What range does is it gives you a bunch of numbers between a range from the start to a finish and a step size. So k is going to go from 1, because remember, oh, wait, no, we do have to start at times 0. 0 to what our max iteration is, which is max iter time -1, and our step size is going to be -1. I put a colon because this is the start of our loop. Everything after the colon and indented is going to be part of that loop. Now it's going to be for I in range. I is going to, because we have our initial values set up already, we want to change those. The borders are going to stay the same. We just want to see how things flow. So we're going to leave the 0 alone, and we'll go to plate length. This is why I want plate length -1. -1, and our values change is going to be delta x colon Next value is for J in range. 1, 2, plate length. -1. Yeah, plate length -1, also delta X, because we have our delta Y and our delta X equal the same to make life a bit easier for us. All right, and there's our J. And now all we have to do is calculate our U. And we can go back to that stencil that we created here. Right? I've actually written down, I have the slides open on my other deck, which is why I'm looking over there, because I'm flip back and forth. So to do that, we have U. Come on. We do my skateboard. K plus 1, because remember that is what we're solving for. U, K plus 1, I comma J. So we're just going to follow that directly. U, K plus 1, comma I, comma J. Exactly how we saw it, equals gamma times all this stuff. So we're going to do the same exact thing. Gamma, we already defined it, times all that stuff, which was, I have it over here, UK I plus 1 J. This is going to be fun. Plus U K I minus 1 J. Oops. And plus U. By the way, if I'm going too fast, feel free to slow down, have me slow down and say, hey, could you explain that? Or why are you doing it that way? Or why does it look like that? J plus 1. All right. Screen, I have it magnified over here. As you can tell, my eyes aren't the best, so I need to scroll over so I can see the rest of the equation. Ki J plus 1 plus U K I J minus 1. J plus 1 J minus 1 minus 4 times U current value, so it'd be K I J plus U K, come on, there we go, U K trying to remember if my syntax is right. U. Oh, come on. There we go. Let's move this up here so y'all can see it, and I can see it then too. Yeah, I could put that last line in the chat so y'all can copy and paste. I'll put this little bit of code in there so you can copy and paste this once I get it right.
Charlie, I think you may be missing parentheses, right? Doesn't gamma multiply?
Yes, that's what it is. That's why it's looking weird to me. Thank you.
There we go.
That makes a lot more sense. It's like, wait a minute, this doesn't look, I'm missing something. All right. Yes, so UKJ, whatever am I? UK, IJK. J. All right, so it's gamma times all of that. And then we still missing a parenthesis though. So go back in here. Open. Okay, plus minus 4 UK plus that. So that's where the parenthesis goes. Okay. So my parenthesis goes right here. That makes much more sense. Now I can see it better. Plus, so minus that, plus that, and then we're going to just return our U that we calculated when we're all done going through those loops. And return U. That. Okay, so that should be our calculation. I'm going to go ahead and copy. Somebody asked for this bit of code in the chat, so I'm going to go ahead and put that into the chat. Can't go that way. Let's see. Okay, so now shift enter that. So everything is now set up. So I should be able to say calculate. Actually, what I need to do now is actually go through, give it values, and then we can calculate it all. U's already set, so I can actually just call calculate U, and it'll pass my variable in there, and then I can see what it looks like. All right, so let's do that. Let's call calculate. I'm going to pass in U, which is what we set up here, right? I'm going to go and pull that empty array that we kind of filled together and put all this initial conditions in. I'm going to pass that into here. It's going to run through my code, and then it's going to return a new value of U. So that's what I want to look at. Shift enter. Cross our fingers. See if it works. It's giving me the busy. So it's got the star, so it's working on something. And look at that. It returned U, and there's all of our values. So, hey, we are done. Thank you for joining us. Not quite, because those are just generic numbers. They really don't mean anything. They're not putting together an image for us, right? And that's kind of what we want to do. The entire goal of this is not just getting numbers that come out, but it's also to go and calculate something new. So that's what we're going to do. We're going to go ahead, and now we are going to plot this thing as a heat map. So I'm going to have another function, definition, plot heat map. All right, so we're going to need our array, and we're going to need a value of k. All right, so each time step, we're going to generate a heat map, and we're going to see what it looks like. And this is another function. This is another bit of Matplotlib. We're going to do PLT and CLF. What CLF does is it clears. The way Matplotlib works is Matplotlib creates what we call kind of a generic canvas. So think about your whiteboard. Each time you fire up Matplotlib, it gives you a blank whiteboard. And then you put stuff on that whiteboard. Like we're going to have the graph and the paper and maybe some labels and whatever. We're going to put that on there. Then we're going to save our whiteboard. We're going to then clear it. And then we're going to make the next whiteboard and clear it, and then the next whiteboard and clear it, and so on and so forth. So hopefully we have a collection of all these whiteboards. Now what we can do with it is we can say, hey, let's animate these hot whiteboards, and we should get a really cool animation of this heat moving through our function. Okay, let's do this. Let's do the next little bit. Let's give it a title. And the title is going to be, we're going to look at temperature. At time equals. All right, well, what does time equals? I'm going to use this thing called, I'm going to embed my values in here. So time is going to equal k, that's our number of steps, times delta t. And that should give us our current time. And where's this going to start unit time? Right, so there's our title. Now we're going to need some labels. Let's label our axes and make things nice. X label is going to be, well, just X. PLT Y label is going to be Y. And what do we get? So now Matplotlib gives us a lot of different options for graphing stuff. We can do histograms, we can do scatter plots. It also gives us this thing called a mesh. And what I like about meshes is it creates this mesh as kind of exactly what we're looking for. It's kind of like a heat map and a contour map. So it gives you this overview of your variables, your values for a particular array. So it takes the entire two-dimensional array and it maps it onto a plane for you, giving you different colors. So that's what we want. We want to plot a color mesh. So it's P color mesh. And what do we want to plot? We want to plot UK. That's going to be what we're going to pass in, our U at any given value of K. There's a thing, if you kind of Google around, you'll find there's different styles of heat maps. For this particular one, I like Jet. So basically, it's the color combinations we're going to use. And our minimum max values. So V minimum is going to equal 0, talking about our grid, and V max is going to equal 100. And just so we have understanding of what we're looking at, I'm going to add a color bar. Now, this is kind of cool because Matplotlib, once you put up that mesh and you have colors coming in there, you can attach a color bar to it, and it'll automatically give you values on that color bar. All right, so now that we have this plot completed, this is PLT, I want to return it. Return PLT. Shift enter there. Now we have our calculate, and now we have our plot heat map. So if we wanted to, let's say, since we have everything calculated already, I could do a plot of a value of K. So I can say, all right, let's say PLT is going to equal plot heat map. And since everything's already been calculated, I can pass it a value of UK. So I can say U, let's look at the 10th iteration and value of 10. And I think we do a plt.show. Haha, look at that. So, oh, my delta X didn't, the time didn't come up. Let's see what I did wrong. I know what I forgot. That's the variable I want to graph. I need to give it a format. All right. And I'm going to say, so it's going to be a floating point with three values after the decimal point. That should be good enough. So let's redefine that and then hit Shift Enter again. Notice this is now 15 because I already ran this one. So this one's 14. So now it changed. So I'm going to rerun this and see if I got, oh, it still didn't work.
You need to put an F before the quotation mark.
Oh, thank you. Thank you very much. Good call. I forgot about that. Sorry, 17. Run that again. Now, there we go. Perfect. I'm not sure who said that, but thank you very much. You would deserve a TACC taco sticker. Unfortunately, there's no way for me to hand that to you. That's kind of what we do in class. I teach a bunch of courses at UT through TACC, and that's what we do when people speak up and save me. So there's our contour map at time equals 10. What about time equals, I don't know, 80? It's time equals 80 as things progress. Just in my opinion, that's kind of cool. Yes, might not be the best of heat maps, but we can change that if we wanted to change what our DPI on that would be, and we can modify that. But for our example purposes, that's perfect. So it looks pretty good. Now comes the point I really want to do, which is animate this guy. Okay, now I'm going to tell you a really cool thing in Matplotlib is called, which we already had up here, which I included, is animation. What animation allows you to do is you can give it a, just like we have an array, we can create an array of plots. And then essentially what we do is we tell, hey, Matplotlib animation, animate this series of plots for me. And then of course it'll say, all right, that would be fun. And it does it for you. Unfortunately, and this is when I was trying to do some sample code, but those of you who are running on a local box, it's fine. So I'm going to create this thing called def animate. Animate. And it is going to be based on K because we want to create a bunch of these plots and we want to animate them all. And so what it's going to do is I'm going to call plot heat map, which is what we have, which is this equation here that we created, or this function here that we created. I'm going to call that plot heat map. I'm going to pass it U sub K, and I'm going to pass it K. All right, so I'm going to call this, animate function. I'm going to give it a value of K, and it should go and have a lot of fun. Okay. Now the way, this is all this function is going to do, in fact, is just going to create those. Now what you do is we usually do this thing called, give it a variable name. I'll call it anim, anim equals animation, because I imported animation as or matplotlib.animation as animation. So I can do animation dot func animation. That's right. This is what do we want to do? I want to plot dot figure, because that's what plot heat map does, is it creates all these PLTs. And I'm going to go into plot dot figure is what I want to calculate. Where does plot figure come from? It comes from the animate function. So we give it this function name. And then how many intervals do I want? I want interval of 1 equal to 1. How many frames? You give it how many frames you want. In our case, our frames are going to be the max number of iterations, which is time. And then repeat. I don't want it to repeat. I just want the animation to start and end. And repeat equals false. False. Shift, enter. Oops, actually, I'm not ready for that yet. I need to actually save this animation that comes up. It works just like on Matplotlib, just about everything else works. Once you do something, you have to save it. And after this is still running, so I'm going to go ahead and hit stop. Notice a little star there. They will recognize my stop. All right. We're going to save this thing, and we're going to call it heat and heat equation. Oh, come on. Animation. And it is going to save it as an animated GIF. That should be everything. Shift enter. Oops, in the line. Oh, line quote. All right. So unfortunately, those of you who are doing this on your own local machine, I bet it worked well. I'm hoping it worked well. For us, doing it on Jupyter Notebooks, it did not work. All right, so what we have, and I'm going to save you guys a lot of problems. What we have is this thing says FFmpeg unavailable. I'm not sure what to use pillow instead. What it really does, or what it's really trying to say here is, hey, FFmpeg, when you do anything with Matplotlib, what it looks at your local machine's graphics card. And it runs this FFmpeg is a library thing that it calls for your graphic card to do something. This Jupyter Notebook is running on a cloud-based system. It's running on this cloud. It's not running locally, it's running on this cloud. Because of that, the cloud does not have a graphics card, unfortunately. So we have to kind of figure out other ways to do this. And so essentially, it's not going to be able to render anything. It's trying to, and it might render the very last slide and show that to us, but I don't think so. I'm going to go and hit stop on that. Stop the kernel, like interrupt the keyboard. All right. Didn't plot anything. Did have a nice color bar. Okay. So this, for our role and our conditions here, it's not going to quite work right. Okay. Well, what will work right? Okay. So what I want to do is I'm going to individually create each one of those plot heat maps that we created. Okay. So the idea is I'm going to save those individual files to my directory. And now what? I'm going to call up this thing from, remember I told you, keep on the back of your mind, this thing called image.io. We're going to use image.io to collect all these GIFs together, and image.io will animate it for us. I hope. It's live coding, so you never know what's going to happen. Okay, so I'm going to clear this. This didn't work, unfortunately, but I'm going to leave it up here anyways, because some of you are using, it might work for those of you doing locally. You open the file on the left side and it worked. Wow. Wow, you're right. I'll be honest, I played with this last night. It did not work. Okay, it saved it for us. Ha, thank you. I didn't even notice that thing got created. The first time I did it, it just gave me blanks. Nothing happened. But hey, this is cool. It's animating it for us. All right, I'm going to show you another technique. All right. This is awesome. It worked. I was not expecting it. I don't know what I must have been doing something really weird last night, because it did not work last night. I got a bunch of errors, and the only thing I got was the very last image. It did not animate it. But hey, look at this. This is our animation function. We're animating a heat wave that's starting. This is a GIF, so the GIF's going to repeat, and it's going to go across. And we did this in, with take away all my conversation stuff, probably about 45 minutes. All right. I am going to show you another way of doing it, which is using image.io. This is pretty cool, though. Paste the code. You know what I'm going to do? I'm going to share the code with you all. I'm going to share this notebook. How do I think that's what I'm sharing is, probably putting it into community data, or we can throw this into Slack if you like. I can also download it as a notebook, and I can post it in our Slack. So there is this DesignSafe Slack that everybody should be invited to. I'm sorry, my camera's over here. There's chat boxes over here. There's this, a box for Slack channels, and there's a training channel in there. I'll post this code and upload it there for you all to use. Okay. Well, hey, that is absolutely awesome. So I'm going to recreate this and let this run all the way through instead of breaking it like I did just a little bit ago. But while that's running, because you've got the little star there, I'm going to show you the other way of doing it. So there's this thing called image.io. And what image.io allows you to do is create these individual GIF files or individual plots or PNGs and combine them together for an animated GIF. So in case you didn't get that animate function to work, anyways, okay, so there's a couple little things that we have to do to get there, okay? Because image.io, if I didn't import, actually it's already on mine, but you all are going to get a image.io not found. So to get around that, if we go back to our launching pad, I'm going to hit plus. I'm going to go here to terminal. So terminal allows you, this is a terminal, ls, change directory my data, ls, it's just a little Linux terminal, right? So what I can do is I can pip, just like those of us who use Python quite a bit and something's not available, you do this thing called pip install. So I'm going to do a pip 3 install. What do I want to install? I want to install image.io, and I need to put that in my user space. So -- user is very important. So I'm going to go install that. My requirements are already satisfied. It's already there. If you notice, it actually did install that pillow that I was talking about as well from image.io. So now my image.io is ready. But if I go here and I type import image.io, it's not going to work. What we need to do is go to kernel and restart. I'm going to say restart and clear all outputs. That just guarantees that my kernel is being restarted because I brought in something brand new called image.io. And okay, for a second there, I thought I cleared out my notebook. It creates this thing called image.io, and now I can actually use that.
Charlie, they're asking for some code to be pasted real quick before you get too far ahead.
Okay, yeah, I saw that. I'm not sure which code they're talking about, just a little plot bit maybe. I'm going to go ahead and put in this heat map code that we just did. Post that here. So that is for creating the individual heat maps. This is this was just demoing that we will do one. This is the animation function. I'm going to control and put that in here as well. Okay. Thank you, Tracy. And then the next thing we want to do is I was telling you about that individual images. So now I'm going to down here, I'm going to go ahead and do an import image.io dot. Now image.io is a new version out, so you do image.io.v2 is what we want to import, and I'm going to bring that in as image.io. And now what we're going to do with image.io, so we're going to do with image, and image has this thing called getWriter. So I'm going to use image getWriter, and I'm going to tell it what do I want to call this GIF? Well, I'm going to call this heat. I'm going to put in my local directory /. So it's going to be in this directory over here. And I'm going to call this heat.gif. Once again, it's animated GIF. And it has a mode. And mode I, to go ahead and create that. I think I need simple quotes for that actually. And I'm going to say as writer. So now I'm going to say with this image writer, do this stuff. Well, first thing I'm going to do is how many images do I want? Well, count is going to be in, so I'm going to do these ranges because I have to create an array of images. You'll see here really quick why. So I'm just going to, just for time's sake, I'm going to only do 100 of them. And I got to create some. So I'm going to create an image name. I'm just going to create a variable called p name. It could be anything you want, be Fred or Bob or Jerry. And that is going to equal, once again, in my local directory, /. I'm going to call it image. Plus str count. This count is a integer. I'm going to cast count as a string, and I'm going to go ahead and create this image based on it. And I'm going to save it as a PNG file, .png. So when this whole thing gets concatenated, it's going to be called image1, image2, image3, image4, and et cetera, .png. Next thing, I'm going to take this image that I created, and I'm going to read it in to my image.io library. Image.io.imread is the command, and you give it a file name. So I'm going to give it that file name I just created, name. And then writer .append. So you have all these images being created. You know what I forgot to do? I actually forgot to run those images. They don't exist yet. Okay, so I have to go back and edit that animate function. One sec, stay with me here. Append data. And where am I going to append that to? I'm going to append it to image. That thing working just kind of blew my head. It's like I wasn't expecting it to work. I never had it work before because of the something must be really cool that I was doing wrong last night. All right, anyways, we're going to write this thing and we're going to write to image. So it's going to be writing to this heat GIF, and it's all going to be all good. So, oops, yes, image.get, images defined. Oh, it's image.io.get, my bad. What would you like now? Oh, these files don't exist. They don't exist because I haven't created them yet. I'm going to go back here. Actually, there's a lot of stuff that I need to restart here again. Oh, image.io again, yes. So if you go here to plus, see this little plus on the corner? If I hit plus, it brings me back to that launcher. So I'm going to go to terminal. And in terminal, I can do a pip3 install. So that is a package manager for Python. So I'm going to do a pip3 install, the name of the library I want. In this case, is image.io. And I'm going to put that into my user space, -- user. Once it gets installed, so I'll go through this entire list. When you go back to your code, you need to tell your code, hey, something has changed. So what we usually do is we call it restart the kernel. And I like to say just restart the kernel and clear all my outputs. So I'm going to restart the kernel. If you notice what happens, look, all of those numbers disappeared. So you have to kind of rerun your code from the beginning. But that's fine, because if you remember correctly, I never created those images. So we're going to create those images now. So if you look at this heat GIF, there's nothing there. And close that out. All right, so yes, so that's what you need to do is restart the kernel after you did the pip install. And now I'm going to write a function that is actually going to create those images for me. So we're going to call Yeah, I guess I could just do 4K in range, and it's going to be going from 0 to max iteration. Whoops, put in my caps lock. Max iteration time -1. And I'm only going steps of 10, just because I want 100 of them, not 1,000, just to make our time go a little faster. These have already been calculated up here, right? This calculate U, that's going to calculate all of my U for me. I just now need to figure out a way of saving the individual images, which is what we're going to do now. I'm going to say PLT is equal to plot heat map. So I'm going to call this heat map function. And so PLT is going to be plot heat map. What am I going to pass it? I'm going to pass it each individual UK, parenthesis, UK, and the value of K that I want, just whatever my current time is. And I'm just going to, now remember, a lot of people, so there is a plt.show, all right? What show does is it shows you the image that's just been generated. And then a lot of people make this mistake. I've made this mistake. Then I say, once I see the image, I want to save the image. And I'll give it a name. Image plus a string value of K. I'm going to cast it as a string, so I can do this. And then .png, because that's the type of file it's going to be. And I can do this and I can run it. And you'll say it's going to run just fine. It's going to create all these images. And then every image you open up, it's going to be empty. Because the way Matplotlib works is it creates you a blank canvas. It lets you put stuff on the canvas. And once you use the show command, it erases the canvas. So the save fig has to come before the show command. plt.show. Save figure as image plus string of the current count, and then calculate it out. And then, okay, count. And then I need to have this thing called count equals, because K's may not be an integer, count +1. And that's your K is an integer, that's fine. No, here. Need to reset the value of count equal to 0. Equals 0. There we go. All right. So count starts at 0. Excuse me. We're going to show the image just for the fun of it, and we're going to increase the value of count. Should create the next image and the next one, and so on and so forth. Okay. Since I restarted my kernel, I'm going to have to restart this code. So shift enter here. And do my variables. And so I'm just going to hit shift enter on all these. I can also just do play and run all cells, but I'm doing these individually because I want to make sure that I'm doing everything right. Calculate U. Create the plot function after the U's done. Yep, there's U. All good. I'm going to now calculate, run that. This was just a sample code to make sure that we can see individual ones. This used that old animate function. I'm not too concerned about that because what we want to do is we want to save these images individually. So I'm going to hit shift enter here. And we should have all these images appear. And they should also then start appearing over here. As soon as they're all done running, but we can see them all. And there you go. There's all my images I just created. So we can save and view these individual images. And there should be 100 of them, right? Okay, this is cool, but once again, and of course, it's just trimmed it out. If I click it here, it'll show me the last 50. This is fine, and this is cool and dandy, but what it doesn't do is animate it for me. This should create that GIF file. Shift enter. Should create that GIF called heat.pn or .gif. So where did that go? There is heat.gif. Pull it open, hit open. And there's another way that we can animate any GIF file. You can also go in there and you can give it, you can feed it other information on how big you want your GIF file to be, what the dimensions of it should be, but there we go. We animated our heat map another way. And now this way, we also have the individual images that we save. Okay, so what's next? Well, we have a few minutes here left. The biggest thing we want to do is, now that I ran this code, and here's the thing, I'm guilty of this too. When I used to run a lot of the simulation code, what I did was I would never save my image or save my data. I would run my code, looks great, plot it, looks great, save it, and go fine. And then I would start a new program from scratch, or take this new program, make modifications and save it again, make modifications and save it again. So I had all these same programs sitting there doing the same exact thing, just giving me different values because I changed coefficients, or I changed boundary conditions, or I changed my initial condition, and I recreated the code. And then if I ever wanted to go back, I would have to rerun one of my older versions. But in this day and age, and the fact that we have DesignSafe sitting here, what we can do is we can create a data frame based on it. So curating a data frame is really simple. We need this thing called Pandas. We can import Pandas. Okay, and I'm going to say as PD, just to make it easier to type. Okay, and now what Pandas does is it creates this thing called a data frame. And so I can do a pd.data frame, and I can tell it what columns I want. So I can say columns, and I'm going to say column I need is a, whoops, this is a parenthesis, and I give it the column names. So I can say value of I, value for J, a value for K, and then my value for U at that value of I, J, and K. And those are my individual columns. And now what I would do is I would, inside of my function here, so let's go back. I'm just going to copy and paste it. I got a lot of stuff here, don't I? I'm just going up in my notebook to my calculate function. So I'm just going to copy and paste this, just so you guys can see what's going on here. I'm just going to control command C to copy it instead of right clicking, because it gives me a different copy function. Go to the end. And now that I have that blank there, I'm going to control V here. Just to show you a little bit of how it's done, I'm going to get rid of this function here as well and take all these guys back. So this is calculating each one of those values of U based on I, J, and K. Now really what I would do is I would just append that to this empty data frame that I created. And to do that, I would just say, all right, data frame is equal to data frame dot append. You take that data frame, I'm going to append. What am I going to append to it? Well, I'm going to give it a list of stuff, because that's what Python is good at. I'm going to give the value of I, and that's going to be I. Yeah, and then a value of J, and that's going to be J, and a value for K, and that's going to be K, and a value for U, and that's going to be U. I'm also going to tell it that, you know what, since I'm not going to give it an index value. In fact, what I'm going to tell it, I'm going to tell it to ignore the index, to ignore index equals true. Just keep things, just save things in the order that they get created. Now that should, whoops, I need to do that. Oh, my list ends, sorry. I'm going to give it a dictionary here. So that ends my dictionary. This is that. And then I'm going to go ahead and say ignore index equals true, throw closing parenthesis, and that should append all my stuff, and I don't need to return you anymore. And at the end of it, what I want to do is look at that data frame I just created, EF. See if that works. So our fingers. Uh-oh. What don't you like? Oh, data frame is capital F. Right. Oh, I didn't, it's deprecated. Oops. Future warning. For the future, use frame.append method instead of data frame. Okay. So it's going to give me that error for every single one of them. But at the end of it, it should use pandas during the cat method instead. Well, it's giving me all the warnings. Unfortunately, every single warning it's giving me before it actually shows me my data frame. But it is actually creating my data frame for me in the background there. I'll have to look at the pandas concat method. I think I normally run things with things being muted when I tested this last night, which is why the warnings are all muted, but these are just warnings. But there's a lot of them because it's every single value of U is creating that warning for me. That's going to be painful to see. But once this thing is in a data frame, I can now export that data frame into a database, into a SQL Server database. I can take that data frame into a CSV file. I can take that data frame and do whatever I need with it. I can query against it. I can run a machine learning algorithm against many data frames and be able to teach a model and be able to see where things go from there. Of course, we're just seeing lots and lots of stuff here. But unfortunately, I am now out of time. So I hope this was kind of useful to you all. I'm sorry my data frame failed here. I forgot to put the ignore warning on there, but it's going to tell me every single one of those lines that are coming up. Okay, I'm going to go, while this thing is running, I'm going to go back to the slide deck here and we'll wrap things up. I do want to say one quick little bit here. All of our training stuff will be archived into our training channel, which I've already showed you on DesignSafe when you first got there. Give me your feedback. I really appreciate everybody's help. Ellen, Tim, Scott, Dan, Scott, thank you so much for joining us on the call. Tracy, thank you for being on the call. And then Natalie, of course, thanks for setting everything up. And Hedda, of course, she's the person who sets up everything on the website. I will also do a quick plug for our next webinar. Our next webinar is Advanced Python Features for Scientific Programming and Engineering. Scott Brandenburg, along with Krishna Kumar, a professor here at UT, will be conducting that webinar for you all. So with that, thank you so much. I really appreciate your time. Once again, I apologize for the bunch of errors that I got, all my future deprecation errors that it's actually still running. But I hope this was useful for you all. I will save and take the program and save it to upload it to DesignSafe. So you all should be able to see that. Plus, I'll save it to our Slack channel, and I'll probably get rid of update my Panda command so it actually does run this properly instead of giving us all these warnings. All right, but the joy of live demos, right? All right. So with that, if you have any questions, feel free to unmute your mic and hit us up or type something in chat. Once again, thank you so much for your time, and we will see you in a couple weeks. Keep an eye out for when Krishna Kumar and Scott Brandenburg's Advanced Python Techniques webinar is going to be up. I've seen bits and pieces of it, and it is really, really awesome. So thank you, everyone.